Hey guys, what is up? For today's video, I'm super excited. The reason is that we're building a proof of work blockchain. Now this project is already there, it's already completed. It's on my GitHub already. So I'm Akhil Sharma 90 on GitHub, follow me. You'll find this project Go Proof of Work Blockchain. It's been lying on my account for about a month. I've been planning to make a video about it, but I've just not had the time. Now I'm back home, so I wanted to tackle this big topic for today. Okay. One thing to remember is that if you find any issues in today's, like when you're coding along with me, if you find any issues, you already have the source code here. You can always come and compare it. Okay. Now the way to make this work, to run this, also I have mentioned them here. Okay. So make sure you follow that at the end once you've done the whole coding part. One more thing that you have to remember is this project is not to be looked at in isolation. Okay. The concepts that we'll be using here, I'm expecting you to know a lot of Golang, because this project will be probably the 41st project on my 40. Right now there's a playlist called the 40 Golang projects on my YouTube channel. So go to my YouTube channel, go to playlists. There's a 40 killer, I think it's called 40 killer Golang programs projects series. Watch that. This is going to be the 41st project. Okay. Now you have to remember that we built a blockchain some time back, right? This was in March of this year. We built a blockchain from scratch, and today's project is going to build on that. In the sense, you already need to know how a blockchain works. I won't teach you from scratch how a blockchain works. You already need to know that. Today is about building a proof of work blockchain. Okay, so we'll be building the blocks and the blockchain. All of that will be there, but I won't spend a lot of time on that. I'll be instead, explaining the other things. So make sure you've built this project already with me. It's a 1-hour project. You'll get to learn a lot about how blockchains work. Build that with me first, and then you have to come here. Okay. Another thing is you have to watch this entire video. It's called Blockchain Visualized for Developers. I made it last year, December 24th, 2021. It has a Santa Claus thing here because it was Christmas Eve. You have to watch this video. You'll be able to visualize how blockchains really work. What is a block? What is a nonce? What is the data that's stored, previous hash, and how the blocks are interconnected with the help of these hashes, right? So that's something that we won't cover today, because we'll be implementing all of this. We won't be learning about this. Learning has to happen in this video. So you have to watch this video, then you watch this video, you build this entire project, and then you come here. And here again, I'm assuming that you have done like many of the projects from my 40 project playlist, right? You're already really good with Golang. Do not expect to understand anything if you don't know Golang. Okay, that's not on me, that's on you. I'm already calling it out. You have to be a Golang pro to build this with me. Okay, so now that's out of the way. So proof of work, many of you would already know that you get a hash. You have to solve for that hash. You have to solve for that problem. So many computers in a network, they solve that problem. The guy who solves it first gets to add another block to the blockchain. Now this blockchain that we are building today is not a peer-to-peer blockchain. Peer-to-peer blockchains are very complex, and we'll be building that in the future. But today's blockchain has just one node, right? Just one node who gets to add multiple blocks to the blockchain, and that one node is going to be running on our local host 8080. That's just one node. Now in a real blockchain, in the real world, you have multiple nodes, and that becomes a peer-to-peer blockchain, and we'll be building that in the future, like I said. Okay, so make sure you understand this, you have that clear in your head. Now like this is building blockchain from scratch, and many of you would think that it's not a very important thing, but it's a hugely important project to build, because you would then understand how blockchains really work from the insides. And then if you have to build your own blockchain using Substrate, Hyperledger, Cosmos, any of those already available technologies, when you have this understanding, the core understanding of how those technologies work, then you'll be able to build much better projects with Substrate and all. Okay, so I think I've given you quite a lot of information. Okay, so yeah, so these videos are done. Okay, now I think we can get started now. There's a lot more things that I will be telling you on the way, like for example the repeat function in strings, and there's a couple more functions with strings. Then I'll be telling you about the spew package in Golang. So we'll talk about that. But I think before we do all of that, right? Before we do all of that, let's take a quick demo of what we're building. So like I said, I've already built this project, so I'll give you a quick demo. So if we run this project, right, go run main.go, that's how you're going to run it. What it does is it starts a server. So firstly, we'll have to build some code to start a server, and we'll be using the mux router for it, because we'll have to hit a couple of routes also. Okay, so it starts a server on 8080, and it creates a Genesis block. Now, if you've done my Golang blockchain video earlier, you know that the code for that is also available on my GitHub, by the way. Okay, so if you've done that earlier, you know what a Genesis block is. It's the first block in a blockchain, and this won't have a previous hash, because the Genesis block doesn't have a previous hash. You store the hash of the previous block as a previous hash in the current block. Okay, and it doesn't have a nonce as well. Now what I'll do here is I know that the server is running on port 8080, the blockchain is running. So what I'll do is, on this other terminal, this is my other terminal, I'll make a distinction between them. I'll make this smaller, put this here. Okay, so in this other terminal, what I will do now is I'll make a post request to the server. So I'm making a post request, as you can see, curl -x post -h, the content type, which is JSON in my case, the data -d is name, and 75. Okay, so name is 75 here, and HTTP localhost 8080. So what I do is I run this, and once I run this, right, what happens is it says do more work, do more work, do more work, like that. Because it's doing more work, it's trying to match the hash, it's not able to match the hash, and it'll keep going till it's able to match the hash. In a while, okay, it's still running, still doing more work. As you can see, it's proof of work, right? So it's making the node do more work, and then it says at the end that the work was done. Somewhere it'll say the work was done. Yeah, here it'll say the work was done, work done. That means it was able to match the hash. Okay, it was able to match the hash at the end, and the hash is this. Okay, this whole thing is a hash. So hash is created with the help of SHA-256 algorithm. We'll be importing that also in our project. And this hash, it's interesting to note that it has a 0 in the beginning, right? 0 in the beginning, and I'm pointing this out, I'm calling this out right now because this is an important detail in our project. So it says work done, and then it shows you the new block that was created. This was the new block that was created. Now it does have a hash of its own, it does have a previous hash of its own, it does have a nonce. Okay, so how do you come to know, how would you know that a new block was created? You can go to the browser and you hit localhost 8080, and here you'll see this was the Genesis block which didn't have a previous hash. I'll try to zoom in because I think now you should be able to see it. So previous hash was nothing, this was the Genesis block, and now this new block was added, right? And the previous hash for this is the Genesis block's hash, which was this F15, 34, 39. This hash is stored in the previous hash, and difficulty is 1. Now what do you mean by difficulty 1 and all of those things? We will cover in a while. Okay, so what we can do is we can get started. We can get started with the code. So I will yeah, so let's create a new project in our Ubuntu terminal. Now, even though I've given you the demo for the entire project, it's still a good idea to just go through everything visually so that you can follow along with me, right? Block is the same thing that we'll be using. Like for the blockchain, you need a block. The block is going to have an index like 0, 1, 2, 3. It's going to have a timestamp when it was created. Data that will store, hash that will be created by adding all these things and then creating the hash using the SHA-256 algorithm. Previous hash will be from the second block onwards. You will be storing the hash of the previous block. Then the difficulty, and then the nonce, which is number only used once. Okay. Then this is what the blockchain will look like, where the first block will be the Genesis block, the previous hash will be empty, so will the nonce, right? And then after that you'll have the previous hash and the nuns. Okay, so to complete this program, we need a server. The server will be started at port 8080, like I said. We'll be using Mux router because it's simple, straightforward, easy to get started with, no boilerplate required. So we'll create a post and a get route here, and post will send the server to handle write block function, which is responsible for creating a new block. And in the post, like I showed you, you have to, with a curl command, you are basically sending some data. The get, which we did from the browser, if you remember, it'll show you the list of all the, this one, which will show you the list of all the data. It'll go to the handle get blockchain function. So this will be handle write block, whereas this will be handle get the blockchain, the entire blockchain. To write the new block, you need to check if the block is valid. So there are a couple of things you can do to check if the block is valid. If the block will be valid if the index of this block is this block's index plus 1, 0, 1, 2, like that's one rule. Then the block could be valid if the previous hash is equal to the hash of the previous block, right? So there are multiple conditions to check if a block is valid or not, and those 3 conditions we'll handle in is block valid function. Then the generate block function will actually do the actual job of creating the actual block, like setting up this data for the block. So all of this work will be done by the generate block function. This to run this function properly, you have to have you have to check the hash, and you have to check, like, calculate the hash, and you have to check if the hash is valid. So this is the whole part where you saw it was saying do more work, because it was checking if the hash is valid. It was comparing with the hash with the data, and it was not matching. So it said, you need to do more work, do more work. And at the end, when the hash and the actual hash they match, that's where it says the work is done, and the new block will now be added to the blockchain. So that's what we're doing. Okay. And many people ask me how I so I build projects with Hyperledger and Substrate and Cosmos and all of that. So many people ask me, how did I get so good at all of that? I don't show all of that on YouTube. I want to build projects around that, but I think there's so less demand, and those topics are so complex, so I don't really make videos on that, because anyways my videos get like 100, 200 views. So it's not, I don't have a big audience anyways. Okay, so now the way I got so great at those technologies is because I understand the basic building blocks. So if you do these kind of projects with me, you build the basic building blocks from scratch with Golang, then you're able to things are not abstracted away from you. So a good engineer is a person who knows what's happening under the surface, and who's not just brainlessly using frameworks and libraries without knowing the what's happening inside, right? Because you're not really an engineer if you just use libraries and frameworks, and then you just I don't know what you are, but you're not like a great engineer. Then to become a great engineer, you have to know what's happening under the surface. Okay, so I always encourage everybody who's subscribed to my channel, make sure you get into the depth of things, make sure you become a really solid engineer. You'll be irreplaceable, as in the job that you do, nobody can replace you then if you know what's happening at the core, at the bottom of everything. All right, anyhow, a lot of talk from my side. So going back here, let's start the project now. Okay, so we've seen the demo, we've seen the visual planning. Now it's time to start coding. I'll create a new directory called proof of work YT for YouTube, and I will cd into it, proof of work YT. Open it up with your code editor. I'm using VS Code in this case. Okay, now in my browser, in my VS Code, there are multiple plugins for that will make me write better Golang code. And what I did was I just went to extensions, and the first 2-3 plugins that will come up when you write Golang or Go, just install those and you'll be good to go. And that's what I'm doing. Now, I don't recommend using extensions a lot or relying very heavily on extensions. Okay, so the first 40, like the first 20-30 projects in my 40 project playlist, I have not used any extensions. Now it really irritates a lot of people who watch these videos, because they say, oh, why are you typing everything on your own? Just use a plugin or extension. Why are you formatting everything on your own? The problem is that, and I've said this many times, is that when you actually go for a job interview at a very serious company, you don't get the plugins that you like. You get like a browser, an in-browser code editor, and you don't get any of the things that you're used to, and then you make a lot of then you get into a lot of trouble, right? You don't get the jobs that you want. So I just wanted to tell you, just wanted to point out just a small caveat. Please don't depend on the extensions. Even if I'm using it, you can use it to code along, but like beyond that, I highly don't recommend it. Okay, so main.go, and you'll have an environment variable .env, and we're not doing much in the environment file. Just one environment variable, like I said, just one environment variable. It's going to be called port, and in my case I'm using 8080. That's usually the port that's usually empty on my like is usually free on my machine. I'm using a lot of things at the same time, usually. So 8080 is always free, so make sure you get a port where you're not running anything important or critical. We're not running some crypto mining nodes or something like that. Make sure you use a node, a port which you can, use without any issues. All right, so here we will follow what we did on the design, right, with the visual thing that we did. So firstly, this is a no-brainer, right? Package main. Importing is a no-brainer. We'll import a few things. If you looked at the diagram, the things that we want to have are the block. So we'll have the block, okay, which will be basically a struct. Then we'll have our blockchain, which will be a collection of blocks, okay. You call it a slice in Golang. You'll have a vector in Rust, so feel free, make sure you also learn Rust. I have this 50 Rust project series going on YouTube. Make sure you learn Rust. It'll really help you in your career in case you want to go deeper into blockchains and all that stuff, okay. It's just a really great language, just like Golang. I love both of them so much, and I make sure I use them on a daily basis. So today I'm mostly building with Rust, so that's why I want to create a video on Golang. And when I'm building with Golang, I want to create a video on Rust so that I touch both of them every single day, so that I don't lose muscle memory. Anyhow, so then you'll have your func main. In between writing code, I keep giving you these caveats and these nice little tips so that you do really well with whatever you're doing in your life. That's the main agenda. It's not just to code, right? My main agenda is to make you a very kick-ass developer. So in your func main is where you'll have all of your, like your logic to create Genesis block, because whenever you, if you remember, you saw when I did go run main.go, it created a Genesis block for us, and then it was waiting for us to open the other terminal and then post some more data so that it can create the other blocks. The run function is basically going to start a server for us, the server that we talked about, which is going to have handlers and server and all of that stuff. Then I will have another function called make mux router. Now I've started my server with the run function, but I also want to have those special routes, right, for get and post, which I talked about earlier. And in my handler, I will have two things, right? One will be the handle is going to make a call to, so I'll have a handle function for the root route. It's going to be get, okay, and I will call my get blockchain function from here. Make sure you get the spelling right. It's not get cockchain, it's get blockchain. By mistake I've written something else. So dot methods, and it's get, okay, with get method. Then you will have another handler function for handling the write block, okay, dot methods and post. So this function is basically going to help me create these two routes, and when I've created those routes, these functions that I've talked about here, I will obviously have some space for those functions. So I'll have this function here called func handle get blockchain, and then I'll have a function handle write block. Now a lot of people, what they do is they start writing the func main, and then they create the functions. What I do, you must have seen this many times if you've been following my projects. Like I don't do it all of the times, but like many of the times, what I do is I create like a very bare bones skeleton of the entire program, like the kind of functions that you would require. Create a skeleton of it. It keeps you like, at least then you have a direction. You have like a North Star where you're headed. Otherwise, it gets very it gets confusing when coding otherwise. Okay, so like try doing this. Maybe you like this approach, and if you like it, then inculcate that in how you work. Create a skeleton first, and then you write the actual inner code, right? And then you will have those other functions that I talked about, which check for is block valid. If the block is valid, right, it is just going to return a Boolean, yes or no, like true or false. Then you had the function to generate the block. Make sure you, if you're having a hard time understanding why I'm writing these functions here, open up the diagram that I just showed you sometime back, and you'll have like complete clarity on why these functions are there. Then you have a function to calculate the hash. This is like the heart of the program. Calculate the hash. Okay, and this returns a string, which is the hash that I showed you. Those hashes I showed you in the terminal, those are that's the hash. Then the last function that we need here is the hash valid or not. This is the one that returns a Boolean, and in the generate block, then you say, okay, the hash is not valid, so do more work. Or if the hash is valid, then the work is done. That's the decision that we want to take out here. One more function that I need is response, to send the response back. So I'll say respond with JSON. Okay. So whenever somebody calls the get and all of that, I want to be able to respond with JSON. Then with handle get blockchain, you will obviously have something here, and you will have this function definition here as well, the same thing. So at least you don't get those errors. So now our skeleton is kind of ready. In the import, I think if I save it, it should get me the HTTP package. Not sure. Yeah, it did get the net/HTTP for me. Okay, that's what I wanted. And let's start with the block now. Okay, let's start with the block. I need a variable called difficulty, and you will come to know why I need it in a while. It's basically a constant right now. It's a constant. And here in the block, I showed you that you need an index, you need timestamp, which is going to be a string. Then you need the data that you want to store there, integer. You need a hash string, and you need a previous hash. Again, it's going to be a string. Then it's going to be difficulty, going to be int. Make sure the difficulty D is capital, because all of these variables we've kept the first letter as capital. Nonce is a string. For the people who don't know about structs, I mean, I obviously don't recommend watching this video if you don't know everything about Golang, but just letting you know, if you don't know what struct is basically your own custom data type, which is a combination of multiple data types that Golang already understands. Okay, so that's a block. Block contains all of this stuff. Then you have a blockchain, which is going to be a collection of the blocks, all of these blocks. Okay, then you have your func main. If you have so as you know that we have a .env file, so we need go.env package to load it and get the server the port data. But here we can also handle, now you can obviously like hard code that value here, but I'm just trying to not do that. Okay, so you get go.n when you get log, okay, in your main, and then you will create a routine which creates the Genesis block for us. Like I said, it's going to have the logic for the Genesis block. So Genesis block, is equal to an empty block. So firstly, you start with the Genesis block, right? This is the thing that gets printed out as soon as you run the program. It's an empty block, block being the struct that you just defined. So this one is empty right now, but we have to put some data into it. So we'll say Genesis block is equal to block, but you'll pass 0 for the index right now because it's the first block, right? So the index is going to be 0. Then timestamp t.string. Everybody knows how to do that. Comma, you get 0 for the data right now because data is 0. Then you get calculate hash, and you say Genesis block, comma, difficulty. Oh, sorry, calculate hash, and then here you just need difficulty, comma. Okay, so this is empty out here. What's empty out here is the previous hash, and what's also empty is the nuns. And for calculate hash, you send the Genesis block, the entire Genesis block there, and you calculate the hash, and the hash will be stored here. And then at the end, like I said, nuns is here, and difficulty is 1, okay, which is a constant as of now. It's going to be 1. So this is your go function. At the end of the go function, like at the end of the routine, you write something like this, and you're going to say log.val, and you'll run the server, the run function. So log and time package and go.env, all of these we need. So I'll press Control S. Let's see if it gets yeah, it got those for us. Awesome. It didn't get go.env. Why? I have no idea why it didn't get go.env. Should have. Anyhow, we'll think about that later. So there is something that I want to talk about now, okay, which I've been holding off till now. It is the spew. Yeah, so these, I think I've shown you these 2 links that you should watch, so I'll just close them off. And I've shown you this link also of the proof of work blockchain, so I'll close this off as well, just to not confuse me. This diagram I've showed you, so I'll close this off as well. This is a video that I'm downloading right now, the restaurant management Golang video that my editor has edited for me, and I'll be uploading it as one big video. So I will keep that open. Now the spew package is what I want to talk about. Now spew package helps you to print out stuff like this without worrying too much about formatting it. Okay, so it's a very handy little package, and you see this kind of output. Now when you when I run the blockchain, I don't know, I don't think I see it here, but when I had run that blockchain, right, the Genesis block and the blocks after that, the data that was being printed out into the terminal, we don't want to hustle too much to print that out, right? We don't want to hustle too much to print it out. So what we'll do is we'll just use spew, and we'll just dump it. Just dump the Genesis block, and spew will figure out how to print it out properly, like formatting the strings and %f, %s, all of that stuff. If you don't want to worry about all that, just use spew.dump. Okay, and we also want now blockchain is like a database, right? And more often than not, it's like it needs to have a lot of consistency, right? So I'm not sure if you're aware about the CAP theorem. C is consistency. So having a lot of consistency basically means that you need to have a little bit of atomicity, which induces consistency. And for atomicity, what we can do is we can have a mutex. Now this is completely, by the way, this is completely optional. You don't have to do this, but but ideally what you would want to have is a mutex block, so that when you're writing something, you can lock it. So we'll say sync.mutex. This is what makes Golang an awesome language, because you get these kind of things right inside Golang. You don't have to get other packages to do that for you. So you get a mutex, and here what I'll do is I'll say mutex dot lock, and we'll now write to the blockchain using append. So we'll say append to the blockchain the Genesis block that I just created, and it's done. That was it. And I will now unlock the mutex. Unlock. All right. So spew is something that should be able to find out on its own. Let's see. No, it wasn't able to find it out on its own, so I'll have to manually get it. No problem, no problem. Okay, so this completes your main function at least. So main function is done. Now comes the run function, which is also important. In the run function, we'll create our little server. So here I'll say mux make mux router, which is basically this function out here, makes mux router. And HTTP port, what's the port that I want? I already have it from my os.get environment variable called port, which is my .env file, which we got with the help of go.end.load. So all of that we have access to. And then I already have my log package imported, and I'll print out the HTTP server is running and listening on port whatever, which is HTTP port. It's listening on this port. So we'll create http.server. Okay, and it'll have a few things. It'll have our address, and it'll have a handler. It'll have a read timeout. It'll have a write timeout. Again, like read timeout, write timeout, all of that is optional again. You don't have to worry about all of these things if you don't want to. And then you have your max header bytes, again an optional field. So I'll make this 10 seconds, time.second, sorry, 10 into time.second. I already have the time package, but it should be referred to in small caps. So this 10 seconds is what I'll have for my read timeout as well. Handler is my mux, and address is my port, HTTP port. Okay. Awesome. Yes. Done. So this is what creates your server. Now you'll say if error is equal to s dot listen and serve, and if error is not equal to nil, you wanna not equal to nil, you wanna hold that, you wanna return the error, and at the end you want to return nil. Okay, so your run function also complete. Now we'll complete this. We are creating our routers, the handling functions for routes. So in the beginning, you want to start off like this: mux router, mux.new router, and here you'll say mux router dot handle func, and then mux router dot handle func for handle write block. Now mux is also something it's not able to get for me, even though I've saved the project. So I think it's a third-party package, so I'll have to get myself. Return mux router. Right. So yeah, so these couple of things, right? Spew and mux and go.env, I think they're third party, so my Go extensions are not able to fetch them for me. So I'll fetch them like this. Okay. Oh yeah, so it's giving me like a red everywhere because I don't have a go.mod file, and I usually don't do that. I always do go mod init in the beginning. And okay, yeah, so we'll init it as something go mod init, and I'll say github.com/ should I do all this or not? Yeah, I'll give the whole thing actually, POWIT, and then you'll go mod tidy it. You'll keep getting all the packages that you want. Now everything looks cleaner, everything looks much cleaner, all the red lines are gone. But there's still issues, right, here and there, because we have not created these functions, we have not like completed these functions. So let's do that. Now at least your make mux router is done. So your handle get blockchain, this is pretty straightforward. You're going to print the entire blockchain. Two things you need here: the response writer and the request writer. So here you'll say http dot response writer and http dot request. So here you'll say JSON dot Marshall indent, and you want to send the entire blockchain to it. So you'll set the blockchain, comma, enter a couple of spaces here. All right. Sorry, this needs to be closed. Yeah. Bytes, comma, error. And here itself, we'll handle the error. So we'll say if error is not equal to nil, this is what the beauty about Golang is. You get to handle the error right there itself. W comma error dot error. Now, like some people feel that with Golang the error handling is not very elegant, and I do agree sometimes that it's not as elegant as something like Rust, where you have that result, okay, and error, right? So it's not as elegant as that, but it gets the job done, and you get to know where exactly the issue is and what kind of issue it is. So, I'm completely all right with that. And whenever it makes you write all of this, at least know in your head, where all the errors can occur and where I should handle them. It's not as elegant, I agree, but it's extremely effective. Okay. So if there's an error, you'll return an internal server error, which is 500. Otherwise, you'll write string, which is W, to the response with the string, which is bytes. Bytes being the entire blockchain, which has been now Marshall indented with JSON. So I'll save this. IO package should be imported. It was able to get the IO package. Okay. And now comes the main area, where you call this function, and we'll write the logic for this function. And this function is basically going to call all of these other functions, which will be generate block, and then generate block will call calculate hash, and is hash valid, and is block valid will be called here. So all of these functions will now get completed because of this one function, which is quite central to our entire blockchain, because this is the one that creates the block in the first place. And to create a block, we have to so many things, right? Generate the block, we have to check if the block is valid, and all of those things. Okay, so let's get started. Okay, so handle write block. I'd gone for a quick break to drink water and to also correct my posture. Now I'm back. Okay, so handle write block. So you have your W and you have your R. So with W you'll get http dot response writer, and with R you get http dot request. All right, here we'll say W dot header dot set application JSON. So with that we'll say content type and comma application slash JSON. Then I want to create a variable called m, which is message, and message is basically on top. You have to create it on top out here, just below. Like actually you can do it anywhere, but I'm just going to create it here below the blockchain, where I have a type called message, which is a struct again, and it's going to have data, and to be able to print out data here. So we'll say where m is message, in your handle write block. Then you'll create decoder. So whatever data is coming from the whenever you make a post request, right, with the data, the decoder is going to decode what's coming in the body. So r dot body. This is exactly what you do for any of the APIs that you must have built with me earlier. You have to first decode that information, and then you'll say decoder dot decode the data is not equal to nil, and you'll respond with JSON saying w comma r comma http bad requests, http dot status bad request r dot body, and then you return. All right, so you need this function respond with JSON, and at the end I'll just defer r.body.close. So at the end, for this function respond with JSON, you are accepting W and R. So I'll say here W, which is http dot response writer, and I'm accepting R, which is http dot request. I'm accepting code, which is an integer, which is like 400 or 200 or whatever I'm passing from here, bad request, or server error, whatever. And then you have your payload, which is the entire body, and it is an interface. Here also I'll set actually the same thing, the same line, just copy and paste it here, the whole thing. You don't have to write it again. To the new developers, I always encourage them to write everything. In case you're new to Golang, make sure you write every single thing. Don't copy and paste, because that's how you'll build an instinct for the syntax. JSON dot Marshall indent payload, comma, then you check for the error. If error is not equal to nil, you will write header http dot status internal server error, write byte of http 500 internal server error. Then you'll just return from here, and at the end you'll say w dot write header with the code and the response. Just write the response. Right, so instead of writing all of this out here, because we want the function to just handle the writing of the block and not working with JSON, that's why we created this special function for it. You don't have to create it, you can write the whole code here itself. Completely optional, okay? Now coming back to handle write block. We have closed the body, and now comes the important part, where again we'll have a mutex log and mutex dot unlock, and between this we will say new block. To create a new block, you'll say generate block, which is this function that we have to work on. Generate block function will create the new block, and here you'll pass blockchain length of blockchain -1 comma m dot data. Okay, because in the generate block you're accepting old block, which is a block, comma data, which is an integer, and you're returning an entire block. Generate block returns an entire block, and that will be captured here in the new block variable. Okay, so you sent the old block, and then you sent the data right now, which we'll send from the terminal, and here at the end you'll get mutex dot unlock. Okay, so that's your handle write function. After this, once the block has been created, you want to check if the block was valid or not. So let's say is block valid, and the block valid function, you'll pass the new block that you just created, and you'll pass your blockchain with the previous data, and in your blockchain, if everything is valid, if the block is valid, you'll append the blockchain with the new block, and to print it we'll again use spew dump and print out the entire blockchain. Okay, So in isBlockValid function, you are accepting the new block and you're accepting the old block, and both of them are of type block, and it returns true or false for if the block is valid or not. So if old block dot index plus 1, so I told you there are a couple of conditions to check if the block is valid or not. So you check if the index of the second block is the previous block's index plus 1. So first you check that. So if the old block's index plus 1, this is why we had to pass the entire old block. So what we're doing here is passing the entire old block. So some of you might say, no, you should have just passed the index or something like that, but that'll lead to a lot of variables. So I'm just passing the entire block here. So if old blocks dot index plus 1 is not equal to the new block index, then we are going to return false. Okay. Right. So we'll return false, then the append won't happen and the printing won't happen. The other condition we can check for, if the old block's hash is not equal to the new block dot previous hash. This is the other. So always the new block's previous hash is equal to the actual hash of the old block, right? The hashes have to be the same, like I showed you. So you will return false if this condition also doesn't match. Third thing is if calculate hash of the new block is not equal to the new block dot hash, then also you will return false. Okay. So whenever you calculate the hash and the hash that it has, they have to match, only then the block can be added. Otherwise you have to keep doing more and more work. You do more and more work otherwise. So at the end you return false. All right. So this is your entire isBlockValid function, and your handle write block function is done here, but at the end you will respond with JSON and you will respond with the status that it was created, http.status created, and then you will also pass the new block, because if everything was done, if the block was valid, the block was appended to the blockchain, you've printed out the blockchain, then you just want to say that, hey, I also want to return in the JSON that, hey, this is the new block that was just created. So this is your handle write block. Okay. So isBlockValid is also done. Now the calculate hash function is left, and your generate block function is left, which we had called out here, the generate block function. Okay, so I think let's start with the generate block function, because that's quite straightforward. All you're doing there is creating the entire block, the struct block with all the data. So here you'll create a new block variable which will be of type block, and you'll start with the time.time.now. Then you will say new block dot index is equal to old block dot index plus 1. Straightforward. New block's timestamp is equal to t dot string. New block dot data is equal to data, and new block dot previous hash is equal to old block dot hash. Then you have new block dot difficulty is equal to the difficulty constant that we have defined, which is hard coded as 1 as of now. To generate block, what you'll do is, so you remember that whole part, right? You're either doing more work or you're saying that the work is done. So you start with I equal to 0. This is I equal to 0. And you say I plus plus, and you'll create the hex here, which will be fmt.printf %x comma I. You print out I, and you get the new block's nonce, right? So till now we have So in the blockchain visualization video, you had seen how the nonce and the hash are related. You have to keep iterating the nonce and then try to match that with the hash. So we'll set the nonce as the hex. So we'll start with 0 and then we'll keep going up hash. And here we'll say if is hash valid, calculate hash of the new block. Sorry, inside here, new block, comma, new block dot difficulty, and fmt dot println calculate hash of the new block, comma, do more work. So if the hash is not valid, like once you calculate the hash of the new block and the new block dot difficulty, you pass all of these things to the is hash valid function, and if it returns false, then you'll have to say do more work. So you'll print out that new block that was created, sorry, the hash of the new block that was created, and you'll just say do more work. You'll have to do more work, and you'll say time dot sleep, time dot second, sleep for a second, and then you continue. But if the hash was valid, then you will say that the work is done, right? Like I showed you in the terminal. So you'll say that the work is done. So you'll say calculate hash new block and comma, you'll say work done. This is inside. Okay, and new block dot hash is equal to calculate hash, again pass new block there, and then you break. So there are two things that can happen. One is that the hash will be valid, which will be handled here, which will say the work done now, and print out the hash, and you'll get the hash for the new block. Or you'll say that the hash is not valid, and then that way you'll say just do more work, like keep running it again. So continue basically means keep running it again and again. But if the hash were matching, then you just break from the loop. You don't have to keep running in this loop again and again. Okay, start from 0, you keep running the loop again and again. Here you'll return the new block, because the new block's hash has been updated now if they were matching. So you'll return the entire new block from here. Now is hash, yeah, so firstly we'll do the calculate hash function. Let's do that. Then we'll do the is hash valid function. Okay, so in the calculate hash function, it accepts the block which is of type block, right? So you're sending the entire new block. Please remember, you're sending the entire new block there. So it accepts a block which is of type block, capital B being the struct block that we've defined there. So we're checking. Here you'll create a variable called record, and you'll say string convert dot itoa for the block's index. So the hash is the entire data. We add the entire data and then we hash it with SHA-256. So it consists of the index and the timestamp. You've seen all of that in the blockchain visualization video. Dot itoa block dot data. So you add data to it, you would add the previous hash to it, block dot previous hash to it, and then you add the nonce to it also. So block dot nonce. Okay, and here you will say edge is equal to SHA-256 dot new h dot write byte and record Okay, so essentially you're adding all of this data, and you're using the SHA-256 algorithm to hash the record, right? Hash the entire record, and the hex that you so the hash data that you get at the end, you will encode into string, and then you will send it, you will return that. That's the entire hash. So calculate hash basically means you get calculating the entire hash and getting the entire hash here. And the hash valid function, you will take the hash and the new block difficulty and then do something here. Okay. So let me show you what we do here. So you say hash, which is accepts, and difficulty, which is an integer. And here all you do is you use a variable called prefix, where you're using strings dot repeat 0, comma difficulty, and return strings dot has prefix hash comma prefix. Okay, so this is a part which is important to understand. So difficulty is 1, right? Difficulty is 1, and strings dot repeat repeats this, which is 0, to the number of times that difficulty exists. So if this was 2, it will repeat 0 2 times. If it was 1, it will repeat 0 1 time. Okay, so this is like the heart of this entire function. So I'm spending more time on this function, heart of this entire program. Sorry, I'm spending more time on this function because this is important to understand. So you create a prefix where you say that strings have to be repeated as many number of times, and you return if that hash that was created has this prefix, prefix being 0. Okay, so in essence, if you repeat 0 just once, what do you get? You just get 0. But the reason we have kept the difficulty as a changeable integer is because you could have repeated that 0 multiple times. So 0 is equal to 2 and then that will become 0 is equal to comma 2, that would have become 2 times 0. And if you say 0 3, it will become 3 zeros, and then these 3 zeros will be prefixed to the hash. So if the hash that you get has a prefix of 0, just once 0, then that means the hash will be valid. Okay, so let me again demonstrate this to you, but I would like to demonstrate this to you, but I think we'll have to run this program first and then solve all the issues actually before I run it. So here I can see there are 6 issues in the file. So let's first fix those and then I'll show you how this exactly works. Or should I actually show you in the previous program and then fix the issues in this program? I think that's a much better approach, right? Because I'll have to explain to you, I want to explain to you what this is doing. So I'll use the previous program that I've built for you guys, and then we'll come and fix the problems here. Otherwise, you will not understand how to fix it. Okay, so I will cd back into it, and I think that program is the POW blockchain. So I'll say cd POW blockchain, and this is the one that I'll say go run main.go. It started running now. Okay, now I'll go to my GitHub. So I'm too lazy to write the curl command, so I'll just come up here and I will just curl it from here. Curl, just copy this, and I will go ahead into another terminal and I'll paste it here. So I will, now there is no HTTP localhost, right? So I'll write HTTP localhost. Just a second. HTTP localhost. I'll make this bigger so that I can see what I'm doing. Sorry, let me just enter this, Control C, Control C. Okay, so here what's happening is content type is JSON. So many things are missing. Let me copy and paste it properly. Actually, so many things that are wrong out here. So I'll copy this and I will paste it here. I don't know why it's not letting me paste. And let me just pause and come back. So I had to like manually type this whole thing, the whole curl command. There's some problem, I don't know, it was not copying and pasting it properly, and also it didn't have this localhost 8080. So I will add that to the I will add that to my GitHub page, that this has to have like the name of the link ahead of this. Okay, name of the link needs to be there, like HTTP localhost 8080. And once you're running this, right, you will see that the blockchain is running. It's doing more work. It'll take a while to keep running and running. And soon it was done, right? So it said work done. Now, why is the work done? Because the first prefix will be 0, right? So the prefix, once it becomes 0, it then matches both the hash prefix based on difficulty. It has to be 0. So once it was done, it matched this. So it said work is done, and it printed out the block, and then it added the block to the blockchain, and everything was done. And now when you look out here, you will see that the block was added. This was the block. Okay. So that's what's happening. Okay. So I wanted to show you that before I actually helped you fix the error. So we'll fix the error together now, all the errors together. So I will go back into my original program, which I was quoting with you guys, which is POWYT, and it's already open, right? And on my screen it's already open, and it has some issues and errors and all of that stuff. So we want to fix those issues and errors, but it's not showing me any red lines. Okay, yeah, red line is because of the FMT package. It's not able to get the FMT package, I think. So I'll manually add the FMT out here. So now those issues have become 4. I'm looking for more red lines to tell me where those issues are. And sometimes if I don't find those red lines, I'll just go ahead and run the program anyways. Because, yeah, so I see it here because there's a typo. It should be sprint F. Okay. So now there are 3 issues. And I'm not able to find those 3 issues. Not able to find any more red lines. So I will just go ahead and, yeah, I think it's green now. It's not red. Okay, sorry. So there shouldn't be any issues now. So let's see. We'll just say go run main.go. Okay, so it printed out the hash for us, the Genesis block for us. And now all we have to do is we have to go to the other terminal and run this. So we're running this, and it should ideally start doing the work for us. We'll do more work, all of that. And at the end, it should say work done. Sometimes this the terminal stops printing out stuff, so just press enter or something, and you'll see that it was able to go ahead. So it said work done, and it's not printed out the work is done. It's not printed out the final block for us. So I think that could be a small issue somewhere. It's not really an issue, but I think I missed printing out the block somewhere here or there. So let's go and check that out. Actually, let me start the blockchain again. Go run main.go. Genesis block is here, and here again we'll make a request to localhost 8080. So it'll keep doing more work. At the end, it should add a block for us. And like I said, there's some problem, like something that I missed somewhere, which is not printing out the final block at the end. But if we go over to the browser, let's see if we are still able to see the entire blockchain. If we're able to see the entire blockchain when we hit the browser, like the get, after we make the get request to the 8080, then everything is fine. Then you don't need to like worry about printing to the browser or printing to the terminal, right? So it's still doing the work, I think. Oh yeah, sorry, its work is done. So the final thing it's not printing out, I'm pretty sure the print line somewhere I've missed out. And let's see if this works properly. So here there's only one hash. It's not added the next hash to the blockchain. That is also an issue. So yeah, we'll have to fix the code. I was thinking that maybe it's just a printing issue. It's not a printing issue. It's actually not adding the hash here, not adding the block here. So that's a big issue. So we'll have to fix that together now. Okay. So it's doing the work is done, but the next block has not been added. So what could be the issue? So I have found the issue, and the issue is a very small issue. Is it should be return true at the end, because there are these three conditions that fail and then they return false. But if no conditions fail, then you have to return true, right? And only then will the block be added to the blockchain. And this was the issue basically. So what we'll do is we'll go back and we will start the server, go run main.go, and then here I will run this. And was it able to? Yeah, so it was said work done. So it was done very fast. Work was done. It matched because the prefix matched, right? The whole hash prefix 0 matched. So work was done, and now we can also go and check in our little browser. So yes, everything works perfectly fine. Just ensure the previous hash is equal to the hash here. So yeah, there are no issues. Everything works perfectly fine. And now we can safely say that we're done. We're done basically with the entire code now. So I hope you enjoyed this project, and I have some really awesome projects coming up now. I have one proof of stake blockchain coming up for you guys, a P2P blockchain coming up for you, and then if you guys want a huge blockchain project where we'll do everything like properly, it'll be like a serious blockchain project, like a production grade blockchain. We can build it together. So yeah, so that's it. So in case you haven't subscribed already, you should. In case you haven't watched the Rust project series, make sure you do that as well. In case you haven't watched the other 40 Golang projects, make sure you do that as well. Okay, so thank you for watching, and I'll see you in the next project or video or whatever.